This is not an electric car, and neither's that, or that, and that's certainly not an electric car. What they are, in fact, are batteries with wheels. It even says so on this display here. But the great thing about these new batteries with wheels is you get some seats, sat nav, and you might even have a sound system there. But today we're going to travel in this battery on wheels to an electrical installation that's part of the future, where this battery on wheels becomes part of the power grid, not just to power your house, but to potentially power everybody's house. So I've arrived here just outside of Ipswich, and this car in front of us here is actually providing power to the grid. We're here to meet Claire Miller, Director of Technology and Innovation of Octopus EV Vehicles, to find out more. So Claire, thanks for inviting me along to see the future. And if you haven't guessed already what we're looking at, it is vehicle to grid technology. So using your car battery, or that battery on wheels, to power this house, but also support the grid network. Why do we need that?
So yeah, batteries on wheels, and why do we need to be doing this? I think it's a bit counterintuitive. Why would I charge my car and then want to take energy out of the battery once I've got it in there because I want to drive my car around? And I think it is that concept of thinking about your car as a car at sometimes and as a battery on wheels at others. So actually, if we can take a bit of energy out of your vehicle and my vehicle, thousands and thousands of EVs in the future, that can really help to support the grid at times when there's a really high demand on the grid. So think about tea time. We all come home, we've got induction hobs, kettles. Actually, across the whole country, we're all doing that. The load on the grid starts to go up and up and up. And to meet that high load at the moment, we have to burn gas. So we want to get away from burning fossil fuels for lots of reasons. One way to do that is actually bring more renewables onto the grid, so wind and solar. We can use that to put in our vehicles when that's abundant. So maybe when it's windy and sunny, we can store that in our vehicles. And then at tea time, when the grid load starts to go up and up and up, we take a bit of that from each of those vehicles when there's high load to share that with your neighbours, share that back to the grid. And the other part, which all EVs can do and are doing more and more, is having a place to store energy made by renewables. Both those things together is vehicle to grid.
Okay, and I mean, I've looked, obviously EVs, the batteries, compared to actually what most people travel on a daily basis, there is enormous capacity in those batteries, isn't it? I don't know what the average commute, 15 miles each way per day, and yet you've got a car that might do 200 or 300 miles. So for most people, that should be trivial, really.
We hear a lot about range anxiety. You know, will my battery take me to where I want it to go? And for most people, these batteries are pretty big compared to what they're doing day to day. So yeah, about 15 miles, maybe 20 miles a day. A 200-mile battery range is going to last you a very long time. We can start to use that battery to help support the grid, help to give a place to store energy. In that way, you know, you're really maximising that battery. So, you know, you might not be driving around that much. And also you might hear cars are parked up a lot. You know, we use them each side of the day often for a commute, and in between they're parked up, using that battery, that vehicle, in lots of different ways, more than just driving around.
Yes, I mean, it's a different way for people to think, though, isn't it?
Yeah, totally. Yeah.
This is, for some people, that sounds common sense, but for other people, you're going to take energy off me and charge me again. I'm thinking pure pounds. Why would I want to do that? What's in it for me?
Why would you want to do that? Because you're a very good Samaritan, Gordon, and you want to share with the grid, share with the world. But actually, you know, at Octopus, the way that we see this working is actually we want to give the customers great tariff coming into their home, but also you're giving some energy back to the grid, you're exporting. So we have a tariff that goes in the other direction as well, where you get paid. Two tariffs, one that comes in, your standard one that goes out, which you might not be familiar with if you haven't got solar, if you haven't got a battery yet. And actually by making the tariff cheap for customers overnight, at times at which they might also be providing their battery to store energy outside of that cheap window. And then for paying customers, when they do give energy back to the grid, again, we have a window of time. And actually outside of that, if there are times when the grid is calling for extra energy, the V2G can get involved in that as well. We can reward customers that way.
So just to unpack that, you've got a really attractive tariff when there's loads of renewables available at night, the wind's turning those turbines. You know, the grid needs somewhere to get rid of that energy and storing it in batteries. But then the flip side of it is you can also earn money by giving some of that energy back when we're in those busy peak periods when the grid's got lots of demand.
Yeah, that's it. And again, at Octopus, as an energy business, we want to give customers confidence that they're getting a really good tariff And we want to make it really simple as well. We are thinking about this as hundreds of thousands of customers. It's our first smart charging tariff, and it does that overnight piece that you mentioned. So actually, we tell your car when to charge and when to not charge overnight to make best use and best support of the grid when it is windy, when there are renewables available. And in return for that, we give customers our best tariff. So it's 7.5p per kilowatt hour overnight at the moment, between 11:30 and then 5:30 a.m. And also the system is so clever that if it detects from a signal from the grid, a message coming in to say, hey, look, it's a really windy evening, we want to charge cars at 10 p.m. or 9 p.m, we'll also give customers that cheap rate at those times as well. We're giving the grid somewhere to put this renewable energy, and we think it's really important that customers can participate in that and get like good tariff for that. Powerloop takes it even further. Vehicle to grid, when you give energy back to the grid, you should have security about what you're going to get for that. And again, our system automatically detects when the grid needs energy, takes in messages coming in from the grid, from your local grid and from the national grid and others, and says, hey, export energy to the grid now, we'll give you this tariff, and if it's exporting outside of those times, you'll still get that really great tariff.
Yeah, because some people like to live and breathe this, and I've seen some of these energy apps. We've used the My Energy one in the past. For a few weeks, it's quite addictive watching the power flow, but then normal life returns and you have to do things, and just having that automatically in the background is great. And you've deployed it in your own house.
Yeah, here we are. We're sitting in my house, and I've had vehicle to grid running since August 2020. I wouldn't want to do something to a customer that I wouldn't do to my own house and my own family. So yeah, we've lived with it here, and actually we've developed like the app, the service, the scheduling. So the whole thing, works on schedules. You let the system know when you want your car back and how much charge you want in your vehicle, and like learning to trust the system. So I've lived and breathed that. I think the other thing that's important is around the limit we won't go below. So we won't go below 30% state of charge when we're exporting to the grid. And that's been really important to build trust and confidence with customers, that we won't take all of their battery. And now we've got some other technology here. We've got the Wallbox Quasar outside, got the G100 export limiting device, which we tested here, prototyped here.
You mentioned the Quasar, so that relies on the Nissan Leaf, wasn't it?
Yep.
And that's feeding DC back out of the car, and you have to have a bit of a special charger there, which is the Quasar, where the power electronics are converting back from DC back to AC.
That's one.
And obviously people will say, well, that's a bit specialist. Chademo's it was an early adopters technology. Is there plans for it to become more mainstream?
Chademo, the combination of the charger, the actual shape of the charger gun itself that goes in the car, and the communications software that goes like between the car and the charger. It was developed in Japan. They started to put more investment into technologies which would give grid resilience at a really like house-to-house level. And actually, we're just starting to think about that now in this country. And Chademo was part of that, thinking, well, if I've got an electric car parked at my home, how do I get a bit of energy out of that car to power the house if maybe the grid around is struggling? It's exactly what we're doing now. So Chademo, really important in this whole vehicle to grid story. That protocol, unfortunately, is the Betamax of the electric vehicle world, and it really is. They've been at it for like 8 years now. But actually, CCS is going to be the charger like standard of the future, and it's going to work to do vehicle to grid with a software standard called ISO 15118. It means that it's going to be the CCS charger, which is the Type 2 charger, pretty standard. It has 2 other pins below, 2 DC pins, and that together is called CCS, that combined charging standard. And the 15118 I mentioned, that international standard, it's just been released about 2 months ago, and that's the agreed way messaging between the car, charger, and maybe other bits of the energy system. But what that's going to mean is that cars coming onto the market in the next 6, 12, 18 months are going to be equipped to do V2G. And then your point you made about the charger is such an important one. Right now with Chademo, the inversion between AC and DC needs to happen off the car. It doesn't have that on board. And that's why the Wallbox Quasar is needed. It's bidirectional charger, has an inverter in there, uses silicon carbide as that kind of switching technology. The Quasar itself is not massive really for what's happening in there, but it is quite an expensive bit of kit because that's all happening in a charger that's hanging off the side of your house. What we'll see going forward, the inverter will be on the battery itself in the vehicle and as part of that vehicle's manufacture, which means that a component that's going to cost, who knows, £400-500 maybe on the vehicle. That inversion happens on the car. Charger on the side of your house can be an AC charger, and it needs to be able to take electricity moving in both directions, but way simpler than the charger that you've seen here today, the Wallbox Quasar. and hopefully that means it's going to be a lot cheaper. Maybe parity with what we pay for chargers right now.
All these AC chargers, they're not really chargers. Just a connection point
I know.
for the charger that's built in the car.
So true.
And the power electronics conversion actually happens in there. We're already seeing it in solar where you get combined inverter and battery chargers. It's almost similar technology that's in the car. And it's interesting, the manufacturers are already starting to think in that direction. We've seen some cars with vehicle to load, and it allows you to power things in your house. Do you think the manufacturers are on board with this? Or is
That's almost a pun.
Yeah.
The onboard charger. I love it, Gordon. No, you're right. I think, we're seeing Hyundai is a really good example. So the Hyundai Ioniq 5 has got vehicle to load. It means it has 3-pin plug sockets in the car itself, and it has an adapter that goes into that Type 2 charging socket and comes out with a 3-pin. So anything that you can plug in a 3-pin socket, that car can power right now. All the conversations that we have with vehicle manufacturers is trying to understand, not necessarily even are you going to do it now, we're getting beyond that, it's when. When will you bring the vehicles with the inverters on board, the bidirectional inversion happening on the battery, and when will you deploy that software that will allow us to talk to the vehicle? So from our perspective at Octopus, we have built this service which is ready right now, and we have the whole experience, and we've trialled that with our customers on this Powerloop vehicle to grid trial. So now it's a case of the cars coming, and I'm really excited to see them come. Hyundai, Kia, Genesis, that family of vehicles, with Porsche. appreciate, lovely to have a Porsche. JLR, VW, all these brands now talking about they're going to bring this technology really soon.
Yeah, because I've looked, people obviously try to sell home battery systems, but you do a little bit of a cost comparison between stacking up 50, 60 kilowatts of home battery and you're nearly at the price of a car, or in some cases you're more than the price of a car. So it's a battery, say, with free seats.
Free seats and radio and in-car entertainment and everything. Yeah, you're right. Some people, it just won't work. For example, I'm sure a lot of your audience, they're out and about all day, using their vans, using their cars. So they're not going to be parked up at home the whole time. So they may be, they're thinking, well, this isn't going to work for me. But actually, even that overnight piece, even making those big batteries available to store overnight is going to be valuable for those people. Again, we're bringing it as part of a really cheap tariff and shifting the stuff that you do in your home that you can to the night time. So it's back to that economy 7 thinking. For a lot of people, their car is parked up a lot of the time, and they absolutely will be able to use their vehicles in this way. And like you say, those cars have got big batteries. We said earlier, you're not using that battery for driving about mostly. Why would you spend all that money on a static home battery system when you can have a car and it's a battery and wheels? Yeah.
And then what do people, obviously people are going to sell cars and range that, but that other thing people worry about is degradation on batteries. And I've been driving EV for 4 years. I've probably experienced 10% degradation over 4 years and the amount of energy I've had to use for 4 years worth of driving is enormous compared to the house. Is that something that people say, well, the car manufacturers are going to worry that you're going to degrade the battery by sucking power out of it?
Every time that battery cycles, it's doing some work. And so if you think about it like when you use an engine, it degrades, it's going to need maintenance, it's causing some kind of damage to the engine itself. The great thing about batteries and the battery chemistries, that battery actually likes to work within a range. It likes to work within sort of 20% to 80%, and it's like an S-curve. It doesn't like to be drained right down to the bottom, and it doesn't like to be forced to charge right up to the top. It likes to be in that, that nice bit of the S-curve. And what we're starting to see from these trials and from some like university research is actually vehicle to grid is a much more gentle way of using a battery than actually driving it, ironically. And so we're starting to see evidence that these batteries are actually being improved by vehicle to grid. It kind of conditions the battery by keeping it in that range. So I'm not expecting to see multiples of improvement of battery life, but certainly no bad effects.
Better to flex the battery on a regular basis rather than just leaving it sat on the drive for days.
The F-150 Lightning, Ford are actually looking at how you use that to power a home in some of those places in the US where, again, the grid is not as reliable. So Texas is a good example. And of course, what's more Texan than having your massive truck?
Carrying lumber.
Loads of lumber. And those trucks are going to power those homes for maybe 2 or 3 days.
And your house is also another first when we start thinking about solar, because DNOs worry, don't they, that everyone's going to be sending loads of power back onto the grid in a little bit of a catch-up mode when it comes to that. Can you explain a bit about the G100 that we had to... the Gs.
The G levels. The DNOs, these distributed network operators, they're the ones that are, they manage the cables from like where the energy is like stepping down from the national grid all the way down to your property or your home. Historically, they've been maintaining that, slowly expanding it where it's necessary, and protecting it. So making sure that energy keeps flowing. And so one of the things they're really worried about is having too much energy going onto the grid at any one point that those cables are just not able to cope with. When we started our project, we started putting in requests to put more energy on. You use something called a G99. Sounds pretty dry, it is pretty dry. And basically, the G99 application is an application which says, I would like to export more than 3.68 kilowatts. And actually that application goes all the way up. So it's the same application as building some new like solar farm or power station as it is for domestic application above 3.68. And actually below that it's G98. So again, some of your viewers might be doing solar installations. The G98 says if you're connecting 3.68 kilowatt or less, then you can notify us after you've connected, because it's low enough that we can cope with that. We're not too worried. Above that, they want you to notify them before you connect. G99 gives you that. So that was a big learning on the trial. We worked with UKPN. They were one of our project partners, and we worked with them to make that a lot easier for installers and make the journey a lot smoother. It still requires someone at UKPN or any of the DNOs to actually go through our application and check, okay, what's the equipment you want to like export using, and what's happening in your local area, how much can the local literally grid network cope with in terms of export. And the G99 gives you an answer back. It's either, yeah, you can connect that, and that's fine, no other requirement. Yes, you can connect, but we're going to give you a limit. We're going to ask you to limit the amount of export because your local area is already quite constrained maybe, or like your neighbours might have a lot of solar already, you might already have solar. Or the third one might be actually that like we just can't do it in your area, that actually there's too much already happening here, and if you want to pay, you can pay to upgrade the grid near you, which is pretty harsh if you're an early adopter, because you're going to pick up the bill potentially for you and all your neighbours to have the grid upgraded. And most people will say, well, no thanks, because it's a big bill. In fact, we had some customers that were 10, 12, 15,000 pounds, which is a huge amount of money. We even had one that was 100,000 pounds because they'd have to have a whole road up. That's just not realistic for most people. But for the customers who, so for those customers, I should say, the DNOs are looking at this slowly but surely. Be patient, they're coming. Thinking about how you help customers so that it isn't one person having to pay, because this is not really fair. So G100 is about limiting the export, and it's a requirement to basically, protect the grid by dropping some of that export down. And so what we wanted to prove was that it is possible in a domestic setting to reduce the amount of export so that we keep below a limit, and that we could apply that to lots of different homes who might have different amounts of solar plus V2G. So what we did was work with a specialist partner, G99 Consultants, to actually design a unit which fits somewhere near your distribution board, which takes the input from the V2G, so literally taking those inputs from the V2G charger, coming back through your home, and putting this device before your smart meter, so it's all happening in the home itself, and comparing that to the solar coming in as well, and then setting each of those units so that they had the right level to meet what the DNO had allowed for that property. And so what we showed is that for those few occasions when it is sunny enough for their solar to be generating enough, and the V2G was also exporting, and the home wasn't using enough energy, so we hit the limit, that device turned off the solar inverter to make sure that we always stay below that export limit. Yeah,
and there's going to be a change, I think, for the DNO as well, and I think they're going to even transition to being digital distribution service operators.
Yeah,
isn't it? And they're kind of, because from the ones I've talked to, they're kind of quite reluctant to do major upgrades to support the EV rollout, and yet you're offering them a kind of way out of it in terms of getting energy back in so they can possibly mitigate some of those upgrades. But the minute they're not very, it's either an on or off, isn't it? It's either you can go to 10 kilowatts or 8 kilowatts. If you go above that, you can't, but they're not really reflecting the real-time demand in the area at the moment. Oh,
it's a really good observation.
Very fixed.
Very fixed. I think you're right. Yeah, so the DNOs are on their own journey to becoming these service providers and thinking more about customers. And I think that's the thing that we've experienced on our project and working with UKPN and actually working with the ENA, the Energy Network Association, who bring all of those DNOs together. Actually explaining it from the customer's perspective has been really powerful to help them understand what they need to do, what they need to improve. So on the project, we, for example, work with UKPN to explain, installers are going to come in number, right? They're going to be asking for these G99 connections for V2G, for battery, bigger solar. They're going to be getting more and more of these requests. And actually they've rolled out something called Smart Connect, a much nicer experience on a website. We can go on, put your application in, it's much more straightforward. So we want to see more of that.
Completed the project. What's the feedback been by the other participants? Is it something they're all delighted and ready for the future, or is it been a challenging world for them to live in?
Well, I think a bit of both, to be honest. It's an innovation trial, and as we were looking for people to join our trial, we were really honest about saying, this is innovation, it's going to be messy, might not always work, but we will work closely with you to help you and support you through this project and make sure that your car is charged and we look after you all the way through. So we're soon going to release some of our reports, actually. So we're going to release a report we did with the Energy Savings Trust, who are one of our project partners, talking about what it felt like to be a customer on the trial. So that's coming really soon. So keep an eye out for that. And actually, the overwhelming feedback is, yes, there were bumpy moments, but we really like doing V2G.
Now, what we really know is the prosumer,
the prosumer.
The producer and consumer. There's a tiny bit in the wiring regulations that hints to the future, but you've already delivered the future. We've seen it here. Everything's still here. Everything seems to work normally. I'm sure the eFix viewers are going to look forward to seeing more of this. If you're watching this, you got to this stage, check out this video here where we went a little bit further on the G100, G98, G99 with the guy who's delivered the project.